Okay, 2.4 deductive reasoning. Students will be able to use the law of detachment and the law of syllogism. These are the two basic laws that we're going to go over today by completing problems as taught. Now, let me just say this. Both of these laws that we're going to talk about are concepts that you've probably used before in your life. They're kind of like common sense, but now we're just kind of going to put some names to it. So let's define a couple things. We've already defined inductive reasoning. That's drawing a conclusion based on an observed pattern. But deductive reasoning, this is when we use facts, definitions, rules, or properties to reach logical conclusions. And this is primarily the type of reasoning that we're going to use when it comes to proofs, because we're going to use facts and definitions and rules and properties. So let's go on to the next page. So here's just an example of some deductive reasoning. The average person knows that if you do not charge your cell phone battery and it dies, it will not turn on. Use deductive reasoning to draw conclusions for the following two examples. Okay, well, thinking back over the last few days, you realize you did not charge your cell phone and your battery is dead. What can you conclude? Now, a lot of people in class would say, oh, well, you didn't charge your cell phone. Well, that's not a conclusion because that's part of the premise here. We already know that that's happening. You realize you did not charge your cell phone. So we're not going to conclude something that we already know. But what can we conclude? Well, if we didn't charge our cell phone and the battery is dead, then the phone won't turn on, right? And that's according to the statement up here, right? That if the battery dies, it will not turn on. All right, now let's look at this other scenario. You go to make a call on your cell phone to find that it won't turn on. Can you conclude that the cell phone has a dead battery? No, right? There's any number of reasons why the phone won't turn on. It's not necessarily that the phone has a dead battery. So we're going to say no. The phone could be broken. So there's a lot of reasons why it could be broken. It could have water damage. Maybe the battery is just completely missing. So there's any number of reasons why the phone won't turn on. Okay, now let's talk about law of detachment. If a general conditional statement and its hypothesis are both true, then its conclusion must be true. So we have some general if-then statement, and then we have a specific example of the hypothesis being true. Therefore, Q, the conclusion must be true. So this is the hypothesis, this is the conclusion. And the important thing to remember here, it's a general statement, and then it goes to a specific example. So here's our example, example 2. If a baseball player is a pitcher, then that player should not pitch a complete game 2 days in a row. All right, there's my general statement right there. General, right? This is for all baseball players, or all baseball pitchers, I guess we could say. And then look at the very next line. Specific. Barry Zito is a pitcher. On Monday, he pitched a complete game. What can you conclude? So here's my specific. Well, we learned that if a baseball player is a pitcher, then that player should not pitch a complete game 2 days in a row. Well, Barry Zito is a pitcher, and on Monday he pitched a complete game. So what can we conclude? We conclude that on Tuesday he should not pitch. Okay, we had a general statement, specific example. So a general if-then statement and a specific example where the hypothesis was true, right? We have a pitcher, we have a pitcher. Okay, let's have another try at it. Given information, if someone is deaf, then she has limited hearing. That should be more general. We should make that say they have. So let me just edit that real quick. Okay, so if someone is deaf, then they have limited hearing. Okay, general statement, right? And then they give us a specific example. Heather is deaf. All right, well, let's break this down into P's and Q's. P being the hypothesis, Q being the conclusion. Hypothesis would be someone is deaf. Conclusion being they have limited hearing. All right, well, let's take a look at this. Do we have a situation where the P part is true, or the hypothesis is true? Yeah, we have a specific person who is deaf. Heather is deaf. So we say if P then Q, all right, that's my if then statement. If P part, if we have a specific example of the P part being true, therefore the Q part must be true. We do have a specific example of the P part, so we can make a statement about the Q. We could say Heather has limited hearing. Okay, let's do this next one together. This is one that I had the students kind of do on their own in class, but we'll talk about it together. It says, if a road is icy, then driving conditions are hazardous. Okay, my hypothesis, road is icy. Conclusion, driving conditions are hazardous. Never mind the horrible handwriting there. Okay. So that's my if-then, my general if-then statement. Now, what does it tell me? My specific statement is that driving conditions are hazardous. Okay, remember the normal form gives me an if, a general if-then statement, if P then Q, a specific example of P, and therefore I can conclude Q. Do they give me a specific example of my P statement? Driving conditions are hazardous. My P statement is a road is icy. No, that is not a specific example of P. It's a specific example of Q. So can I make a conclusion? No new conclusion can be reached. And that's because, just because, let me finish writing this. Just because the driving conditions are hazardous doesn't necessarily mean that it's because the road is icy. Right? There's any number of reasons why the driving conditions can be hazardous, right? Like the road could be flooded, there could be a fire, there could be a giant accident on the road. There could be a bus full of clowns that spilled all over the road, who knows, right? Any number of reasons why the road conditions or the driving conditions can be hazardous. So we have to understand that if we only can make a conclusion if they give us a specific example of the hypothesis, not a specific example of the conclusion. So that's law of detachment. A general statement, specific examples. Let's go on to the next page. Let's talk about the law of syllogism now. This one says if two conditionals are true and have common aspects, then they are linked. So if we have two if-then statements, if P then Q and then if Q then R, therefore we could skip the Q part and we could just go make a statement from P to R. Notice the conclusion here is going to be the same as the hypothesis in the second statement. That's the law of syllogism. So let's give you a specific example. It says if a number ends in 0, then it is divisible by 10. That's true. If a number is divisible by 10, then it is divisible by 5. Okay, that is also true. Notice my conclusion is the same as my hypothesis in the second statement. So let's write out the P, Q, and the R. We got a number ends in 0. And then we have a number is divisible by 10. And then we have a number is divisible by 5. Okay, so let's check. If a number ends in 0, then it is divisible by 10. If a number ends in 10, then it is divisible by 5. Or if it's divisible by 5, then it's divisible by... If it's divisible by 10, then it's divisible by 5. Well, we can skip this middleman, and we could skip the Q part and just say if P then R. So if a number ends in 0, then it is divisible by 5. And that would be my conclusion. If a number ends in 0, then it is divisible by 5. All right. That's all the law of syllogism does, is lets you take two if-then statements that are linked because we have the same conclusion in one as a hypothesis in the other, and it lets you skip the middleman and just make one if-then statement. Okay. What I want you guys to do for your summary is to write two of your own statements, one that uses the law of detachment and one that uses the law of syllogism. So try making up your own example of both. Okay. See you guys on the next video.